Hey guys, in this video I want to derive the quadratic equation, which I think needs no introduction. So when we talk about the quadratic equation, we know that there are three main ways to solve it. So one is factorization, the other is completing the square, and last but not least, the quadratic equation, which we will be attempting to derive in this video. Now, I want to focus on the I want to show you how completing the square actually leads you back to the quadratic equation, and I want to show you the logic behind completing the square. Obviously somebody came up with those steps, and for good reason. So we'll have a look at that in this video. First of all, let's just add a little bit of color. So we'll use these colors for our constants. So a, b, and c, this is the general form of the quadratic equation where a, b, and c are all constants. So whenever we try to solve any kind of equation with a single variable, which in this case is x, a single unknown, we try to isolate the unknown part. However, in this case, it is a little bit tricky because we have this pesky squared term here and the term of an order 1 term here and a constant term here. So what can we do? Alright, so what we can do is we can actually realize that there are some properties of some functions, of a function that can be written in this form, say x plus, I don't know, let's call this variable as q. Now, as it turns out, if you square this and open it up using the FOIL method, this is what we'll get. We'll have an x, and I think I will use a different color for this q. Maybe let's go for a red. Yeah, let's go for a red. Alright, so this is what we'll get. Now I'm going to use pink to show the direction of the FOIL method. This x multiplies by this x, multiplies by this q multiplies by this x, and this q multiplies by this q. So when we break it open, we find that we have x times x plus x times q, again, plus q times x, and finally q times q. So this is what we get, and that simplifies nicely to x squared plus 2xq plus q squared. So why is this an important realization? So as you can see, from this simple bracketing of x plus q, we managed to extract a term where we have a 2xq. So this 2 seemingly came out of nowhere, but it actually just came out of the FOIL method. Now, why is this so particularly important? Well, if we go back to our quadratic equation, it seems like we might be able to put the quadratic equation in such a form that allows us to, when we perform the FOIL method, to be able to reobtain our second term here, b. Now, we also need to recognize that when we are using this FOIL method, the coefficient of x is 1. However, in the general quadratic equation, the coefficient is not 1, but rather a. So let's revisit the definition. We have a, b, and c here. Ax squared plus bx plus c is equal to 0. So now we want to get rid of the coefficient a, and to do that we're going to be dividing the whole thing by a. So we know that a divided by a is simply x squared, and we can actually leave the rest. 0 divided by a is obviously 0. B over a is just b over a because there are some constants, and c over a is also c over a. And now we have a coefficient of 1 in front here, and this will allow us to use the FOIL method to group this term in this way. But the issue is we have a BA over here, but here we have a 2xq. So how can we get around this? Well, this is where the genius idea of completing the square came about. So whoever came up with this method, what they did was write b over 2a inside this brackets. So this, when we do the FOIL method, actually allows us to write something like this. So we have our x terms, our b over 2a terms coming. Oh, my bad, the b should be in the numerator. You say using the FOIL method, x multiplies by x by 2a, b over 2a by x, and b over 2a by b over 2a. So when we actually break this apart, we find that we get, oh, it's still pink. Well, since I can't seem to change color at the moment, or can I? Okay, I can. This will give us x squared plus b over 2ax, another b over 2ax, and finally b over 2a all squared. So this simplifies neatly to b over ax, alright, plus b over 2a all squared. Okay, so we've gotten that out of the way, but now we want to go back to this definition where we have x squared plus b over ax plus c over a. So we can actually rewrite that as follows. We have our x plus b over 2a all squared plus c over a. So this is b over 2a all squared plus c over a. However, we need to recognize one thing, is that there is this additional term of b over 2a all squared whenever we do this FOIL method. So in order to preserve the original value of the quadratic, we need to subtract this. And I'm going to write this in pink now. And finally, we are able to equate this to 0. And now we are able to solve the quadratic using and completing the square method. So all we need to do is just rearrange everything so that we have this bracket with x in it on one side, and we have the constant terms on the other side, like so. So now we can take the square root of both sides, but before we do that, I would like to simplify the right hand side further. So we can expand this to become b squared over 4a squared. And this is still being subtracted by ca. Now if I want to put everything with the same denominator, this is what I'm going to have to do. I'm going to have to multiply this by 4a and also this by 4a. So now what I will have is b squared minus, and I hope that is starting to look a little familiar to you now, b squared minus 4ac all over, oh, you know what, I'll just use pink for this. This is going to be all over 4a squared. Alright, so now I want to square root both sides. We still have our b over 2a over here. So when we square root the left hand side, we also must square root the right hand side. So this will give us plus minus, I'm just going to use white now, b squared minus 4ac all over 2a. And I think it's becoming increasingly clear what's going to happen here. So we still have x plus b over 2a on this side. Lastly, we can write x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's it. We have derived the quadratic equation from the completing the square, but not only that, we have also demonstrated the ingenuity behind completing the square by recognizing that we can put the quadratic equation in this form by squaring an x plus constant term and dividing that constant by 2 in order for us to be able to extract back the original value, and finally subtracting by the product of the constant term by itself, giving us back the value of 0. And when we go through this process to simplify, we get back the quadratic equation. And I think that's absolutely beautiful. Please like, leave a comment, and subscribe. Also click the bell icon for for notifications. Thank you for watching, and stay tuned for more. Bye!